Okay, ZRX fans, this is a quick shifter, design and build, homemade, made at the request of TrackMedic, one of your own. This is the kill box, which consists of various electronics and two hunky power transistors designed to interrupt the spark on the two-coil wasted spark system that the ZRX1200 uses. This has been completed, finished, and tested using spark coils, and it's ready to go. Now, it's originally set up to use a micro switch or any kind of contact closure associated with the shift switch on the shift lever. Now, that's the way we decided to build it to start with. But in the meantime, we have developed a prototype or a bench test of a strain gauge shift switch that has no moving parts, and you can see it here. The actual strain gauge is a dual strain gauge. It's actually two strain gauges in one. That means there are four wires coming off of it that are bonded to this 1/8 inch by 1/2 inch steel, mild steel bar stock. The whole idea is that this little beam will become part of the shift mechanism, and when it is stressed, it will generate the signal without moving or having to move for the shift signal to actuate the time delay in the kill box. So let's see how it's going to work. Here is the schematic diagram, and these four wires here represent these two strain gauges inside a Wheatstone bridge. Here are the other two precision 350 ohm resistors. This creates, the stress on this beam creates a differential voltage, a very small differential voltage that's measured by this highly accurate instrumentation grade operational amplifier in the first stage, which then sends a signal to an LM358 general purpose operational amplifier that's set up as a differential amplifier, and we compare the signal that comes out of the first operational amplifier to a set point that we set with this little blue trimmer pot right here. And by using this trimmer pot, we can actually set the amount of force that is required to trip the circuitry to actually actuate the shift module. So from there, the signal goes to an output transistor, which in this case is driving an LED. Now let's see how it's going to work. Let's hook the power up to it. 12-volt battery. Okay, now watch this little LED as I start to stress this beam. You can see with just a little bit of stress on the beam, very little movement at all, the LED lights. And every time it lights, that's an indication of when the shift box will kill the ignition. And so this is fully adjustable by using this little pot. So the trick is now we need to make a little 2-inch butterfly beam about this long, attach one shift rod to one side of the butterfly beam, the other part of the shift rod or shift linkage to the other side of the little butterfly beam, and put a strain gauge on each side. Encapsulate it in epoxy to protect everything, and then you have a non-moving, no moving part strain gauge, fully adjustable for the shift pressure, shift sensor, that's going to cost one hell of a lot less than what Dynajet charges for theirs. And here's the stainless steel. This is carbon steel, by the way, but I have purchased some 304 stainless steel stock that I plan to polish up and use for these beams. And hopefully I'll have TrackMedic's prototype up and running in a week or so.